Very good afternoon. The 43rd module, unit for algebraic structures. So today we are going to see for normal subgroups and quotient groups. So that is also one more important topic. One more 8 marks we can expect from the normal subgroups. And also one more very most important theorem, fundamental theorem of homomorphism. That is also most important theorem in this topic. That is a quotient group topic is there. So normal subgroup is the one more 8 marks we can expect it. And Lagrange's theorem also we can expect 8, 10 or 16 marks. And also the kernel of the homomorphism also we can study. The kernel, sometimes they're asking most important 2 marks and lot of things is there. And we can expect 2 mark is rings. And the last topic is rings and field, only definition and examples. That is also we can expect for 2 marks. Okay. Before entering the, what do you mean by the normal subgroup? What is the definition of normal subgroup? Normally, you know the subgroup. Subgroup is nothing but if G is a group, then H is a subgroup. Easily we can show that A star B inverse belongs to H, then we can say that H is a subgroup of G. In general, identity element is common and H also satisfies the 4 conditions: closure property, associative property, identity, and inverse. If these 4 conditions should be satisfied H, then it is called H is a subgroup of G. The elements of H, take it from G. Entire G also you can take it as, or some of the element left out remaining you can take it as from G. That is a subgroup. Subset it converted into subgroup. When satisfy the 4 conditions. Abelian is nothing but commutative law should be satisfied. So a subgroup H comma star of G comma star. A subgroup H comma star of G comma star. G in the group, H in the subgroup is called a normal subgroup. If you can say it is said to be a normal subgroup, we can specify a special name. It is a normal subgroup. If for any A belongs to G, take any element from A. Any element G choose panninga. For any element A belongs to G, such that AH equal to HA. Normally AH அப்படிங்கிறது left cosets. அதாவது H ஓட ஆப்போசிட் டைரக்ஷன் சொல்லணும்னு சொல்லிங்க. ஸ்மால் a டிபெண்ட் பண்ணி கோஷெட் சொல்லணும். Small a first வந்தா left coset, small a second வந்தா right coset. Every left coset it should be equal to right coset இருந்தா we can say it is a normal subgroup னு சொல்லணும். So definition of normal subgroup is a left cosets equal to right cosets. Or one more definition also next we can write A star H inverse also we can write. That is also one more the property of normal subgroup. Note, it was Galileo who recognized that the normal subgroup are distinguished once in a Galileo's theory. So Galileo's AH equal to HA does not mean A star H is equal to H star A element device. It is not each and every element not should be same. It only means A star H is equal to H1 star A for some H comma H1 belongs to H. Some other element may be same. So A take it from the set G and H is take it from the set H. Once you can multiply, these 2 values are same. Some A value multiply with the 2 different values of H, we can get the same answers. That is also is acceptable for AH equal to HA. Like the example is 1 minus 1 I minus I plus I. That is you can choose A as I. So I into 1 also you can get the I. And I into I cube, like etc. That is also you can get the same value. Third point, if H is a normal subgroup, then HA equal to AH for every A belongs to G. And so we may simply call them cosets. That is called as a cosets. In any group G comma star, in any group, if we can take it as a G comma star, any group G comma star, the trivial subgroup, that is identity and star. Identity மட்டும் வச்சு group form பண்ண முடியும். Only identity மட்டும். For addition க்கு 0, multiplication க்கு 1. And identity மட்டுமே, ஏன்னா inverse க்கு exist, inverse ஓட identity ஓட inverse identity தான். Inverse exist ஆகும். Closure ஒரு element தான், closure, associative, identity, எல்லாமே everything is there. That is a trivial, obviously. Only one element. That is a trivial subgroup. E, singleton E, comma, star the operation. And G comma star or normal subgroup of G. Any group has a trivial subgroup of, and this one of the subgroup. One element subgroup, all the elements are subgroup. So singleton E comma star and G comma star are normal subgroups of G. Next, what do you mean by the quotient group or factor group? You can call it as it's a quotient group or factor group. Let N be a normal subgroup of a group G comma star. Then the set of all right cosets of capital N. Normally here telling the name as N is a normal subgroup, indicating normal. That's why I can choose it the subgroup name as N. Normal subgroup, normally we can call it as H in use pannuvom subgroup. Normal subgroup ku notation வந்து N use pannuvom. The set of all right cosets of N in G be denoted by G over N. That is equal to set of all NA such that A belongs to G. G over N divided அதான் quotient P by Q fraction எழுதுவோம். So the G over N that is equal to set of all NA such that A belongs to G. Now we define a star operation as binary operation on G over N as NA star NB equal to N of A star B. So N of A star B the operation. So then G over N comma star will form a group called quotient group. This is the definition of it's a quotient group. G over N is called a quotient group. It should be satisfied NA star NB equal to N into A star B. Note, if G is finite group and N is a normal subgroup, if G is a finite group and N is a normal subgroup of G, then order of G over N is nothing but order of G divided by order of N. G it should be countable number of elements. G is a finite group and N is a normal N is the subgroup, it should be normal subgroup. Normal condition satisfied. Every left coset is equal to right coset. N is a normal subgroup of G. Then order of G over N that is equal to order of G divided by order of N. If G comma star is a abelian group and N comma star is a subgroup of G, G is a abelian group, N is a normal subgroup of G, then the quotient group G over N is an abelian group. G abelian and automatically G over N also abelian. No need to check, that is a statement. The most important theorems are proof. N comma star every most important for subgroup like A star B inverse belongs to H proof பண்ணிருக்கோம். அதாவது if H is a subgroup of G, if and only if A star B inverse belongs to H, for all A belongs to H. This is a subgroup for all A belongs to A comma B belongs to H. Then it is called a subgroup of G. Same like that, if N comma star is a normal subgroup of G comma star அப்படின்னு சொல்லணும் அப்படின்னா if and only if A inverse belongs to N. A inverse belongs to N. For all N belongs to capital N. N all the element it should be satisfied A inverse belongs to capital N. And for all A belongs to G. For all N belongs to capital N and A belongs to capital G. That is a normal subgroup of G. So a normal subgroup it is enough to show that this cases. If and only if, meaning you can try to go for one by one. Take the left hand side, you can prove the RHS. Take the RHS, you can prove the right hand side. Left hand side, then you can show that the right hand side. You can take the RHS, then you can take the left hand side. That is a if and only if. The statement of the proof like if and only if. Around 125 students only is joined, nearly 126, including faculty. So try to inform your friends, try to join. At the earliest, try to join. So first of all, you can assume that let N comma star be a normal subgroup of G comma star. N comma star be a normal subgroup of G comma star. I like to take the assumption. But therefore, N is equal to N. N equal to N. For all A belongs to G. N is equal to N. For all A belongs to G, I can take it as. Okay. In a normal subgroup, it should be satisfied AH equal to H in bottom. AN equal to N for all. By AN, A inverse. Post multiplying by A inverse on both sides. AN equal to A inverse into A inverse equal to NA into A inverse equal to n into a dot a inverse is the identity element. This is I can write an க்கு பதிலா n மாத்தி எழுதிக்கணும். ஏன்னா every left coset should be equal to right cosets. அதான் normal subgroup. Questionல இருந்து I can assume the left hand side. Assume that n is a normal subgroup of G. இது assume பண்ணிட்டேன். Now I need to going to prove an a inverse belongs to n ன்னு சொல்லணும். So I can assume that n is a normal subgroup of G. So that's why n is a normal subgroup of G ங்கனால an equal to n ன்னு எழுத முடியும். For all a belongs to G, then the definition we can write an equal to n. That I can write in the note. An is equal to n. Ah is equal to h. Ah equal to ha. Normally we can write h now. So that's why an equal to n. So for an equal to na also we can write na inverse identity, that is equal to n. So therefore an a inverse equal to capital N. In the equal to belongs to a small n எழுதுவோம். நார்மலா an a inverse equal to capital N எழுதுவோம். இந்த small இந்த capital n small n கன்வர்ட் பண்ணீங்கன்னா a small n a inverse belongs to capital N மாத்தும். ஏன்னா a h equal to h னா a belongs to h. A small h belongs to a star h belongs to h. That's the definition. Coset order definition. An அப்படின்னா a star small n belongs to capital N ன்னு சொல்லுவோம். That is a definition of left cosets. A star small n. The n belongs to capital N, which is belongs to capital N சொல்லிக்கலாம். Using that property, therefore I can prove the left hand side. I can prove the RHS. Now I can go for the RHS. Right hand side value. That is a conversely. Assume that a inverse belongs to n. The conversely, I can assume that a inverse belongs to capital N for all n belongs to capital N, and for all small a belongs to capital G, and for all small a belongs to capital G. To prove an equal to na, that is every left coset, it should be equal to right coset, then we can say n is a normal subgroup of G. Every left coset is equal to right cosets for take it as any element, then you can say it is a normal subgroup of G. Let x belongs to a. One element I can take it as an. இதே element na ல இருக்குன்னு சொல்லணும். அப்ப na ல ஒரு element எடுத்து அது an ல இருக்குன்னு சொல்லிட்டோம் அப்படின்னா ரெண்டும் கம்பைன் பண்ணும்போது ஈக்குவல் டு கேஸ் வரும். So I can take it as let x belongs to an choose பண்ணுங்க, which implies belongs to a you can convert it into equal to, you can write small n. அதான மீனிங். அப்ப x is equal to a star small n for some n belongs to capital N. X is equal to a star n. an a inverse belongs to n ன்னு சொல்லியிருக்கோம். ஸோ அதனால ஏக்கு பதிலாக an a inverse. ஏன்னா ஏங்கிறது ஒரு எலமெண்ட் இன் n. nல உள்ள ஏதோ எலமெண்ட், எனி எலமெண்ட் இன் n. So that's why I can choose it as an a inverse எலமெண்ட்டை நான் சூஸ் பண்ணிக்கிறேன். an a inverse star a. பாசிபிளா? an a inverse star a. நான் an a inverse belongs to capital N. அப்போ அந்த ஸ்மால் n-க்கு பதிலாக I can choose this value now. an a inverse. அப்ப x belongs to n a. This element is belongs to capital N, இது a. So it can be expressed as the right cosets. This is a capital N. So belongs to போடும்போது it should be capital N a. So I can take a element in an which is equal to n a by the help of an a inverse belongs to capital N அப்படிங்கனால இது possible. an inverse belongs to capital N ல இருக்கனால we can write the term, we can take it as an a inverse star n. So an is a subset of na. Similarly, you can take it as some element in the codomain. So RHS values are y belongs to na. Now y can be expressed as n star a for some n belongs to capital N. Then y is equal to a star a inverse star n star a. So this can be expressed. ஏன்னா இது எப்படி எழுத முடியுது அப்படின்னா a star a inverse வந்து ஐடென்டிட்டி. ஆக்சுவலா n star a ல நான் ஒரு ஐடென்டிட்டி எலிமெண்ட் ஆட் பண்றேன். e star n star a ன்னு எழுதிக்கிறேன். அந்த e next stepல I can write a star a inverse மாத்திடுவோம். a star a inverse star n star a. Then I can apply the associative law apply பண்றோம். இந்த ரெண்டு ஸ்டெப்புக்கு முந்தின ஸ்டெப்ஸ் வந்து அதான் மீனிங். First step we can change it as multiply by identity e. Then replace the identity e by a star a inverse. Then it can be using for associative law a star a inverse n a. அப்ப a star a inverse n A inverse, the whole inverse A எழுத முடியும். இன்வர்ஸுக்கு இன்வர்ஸ் எடுத்தீங்கன்னா it should be the same element. Transposeக்கு transpose. நான் matrix யூஸ் பண்றேன். So that's why you can take it as A inverse to the whole inverse. So which is belongs to AN. So இதுல இருந்து choose பண்ணா இங்க இந்த வேல்யூ. இது equation number 1. Then this is the equation number 2. From 1 and 2, subset cancel equal to mother. ஒன்னு contained others அப்படினா automatically it should be equal symbol on the equality of the set. Okay. So that is a very most important theorem. N comma star is a normal subgroup of G comma star if and only if A and A inverse belongs to N for all N belongs to capital N and for all A belongs to G. And next prove that the intersection of two normal subgroup of G comma star is a normal subgroup of G. This we can expect 1.8 mark. The intersection of two normal subgroup is again a normal subgroup. I mean, subgroup use பண்ணிருப்போம். Intersection of subgroup is again a subgroup. Union of subgroup is also a subgroup. Only the condition is one should be contained the others. A contained B or B contained A. That is a H1, H2. Your condition is yeah, I think both. It's a normal intersection of normal subgroup is a normal subgroup. Just to see that, what is let N1 comma star and N2 comma star be two normal subgroup of G comma star. Upon to N1 intersection N2 comma star is a normal subgroup of G comma star. Okay. Clearly N1 intersection N2 is a subgroup of G. Clearly N1 intersection N2. And already we can study it. Intersection of a subgroup is subgroup in படிச்சிருக்கோம். இது வந்து நார்மல் கிடையாது, ஜெனரலா subgroup ன்னு எழுதுறேன். N1 was subgroup, N2 was subgroup. Intersection of two subgroup is again a subgroup. So அதனால N1 intersection N2 is a subgroup of G. Since S1 and S2 are subgroup of G, we can choose like that. But now only we need to prove that N1 intersection N2 is a normal subgroup. But normal subgroup நமக்கு ஒரு condition சொல்லுங்க. If N is a normal subgroup of G, depend only if A inverse belongs to capital N. Okay. But to prove A N star A inverse belongs to N1 intersection N2. So for all A belongs to G, for all the symbol of the for all N belongs to N1 intersection N2. But let N belongs to N1 intersection N2. Let N belongs to N1 intersection N2 be any element and A belongs to G be any element. N belongs to N1 intersection N2 be any element and A belongs to G be any element. So then N belongs to capital 1 N1 and N belongs to capital N2. So A inverse belongs to N and A inverse belongs to N2. Since N1 and N2 are normal subgroups, we can write like this way. A inverse belongs to capital N1, A inverse belongs to N2. So therefore, A inverse belongs to N1 intersection N2. N1 N2, that's why we can say this that A inverse belongs to N1 intersection N2. Okay. Right, next one more important proof. One more thing. If G is the additive group of integers, addition, and H is a subgroup of integers, an integer or a subgroup, and H is a subgroup of G defined by H is equal to set of all 4x such that X belongs to G. Multiples of 4 natural elements. Write down the elements of the quotient group G over H. Also find the composition table for G over H. Composition table கண்டுபிடிக்கணும் and the element of the quotient group G over H. First of all G is set of all integers about 0, plus or minus 1, plus or minus 2, plus up to etc. H is multiples of 4 and the G is the sum of the quotient. So G is over elements you got to multiply by 4 multiply up to till infinity times. It is not a finite subgroup, it is an infinite number of subgroups. H is a subgroup of G. Choose the left cosets of H are G லோட ஒவ்வொரு எலமெண்ட்டையும் ஆட் பண்ணிக்கணும். Once you can add 0, you can get what is the value? Same H. When you can add 1, then you can get add putting out the value. So once you can add 1, automatically the value -7, -3, 1, 5, 9, like etc. Similarly, add 2, then -6, -2, +2, 6, 10, 3 plus h, 4 plus h போடும்போது திரும்ப அதே ஆன்சர்ஸ் வரும். ஏன்னா நம்ம கோஷன்ட் மல்டிபிள்ஸ் ஆஃப் 4னா 0, 1, 2, 3 மட்டும் தான் நம்மளால போட முடியும். மொத்த 4 எலிமெண்ட் ஸ்டார்ட் ஃப்ரம் 0, 0, 1, 2 and 3. இந்த 4 மட்டும் நாட் இருக்கும். தட் ஃபார் 4 அகைன் h உள்ள வந்து. That 4 plus h is equal to h. 5 plus h is equal to 1 plus h. 6 plus h is equal to 2 plus h. So clearly that for 4 distinct left cosets in G over H. There are 4 distinct left cosets. 4 left cosets, remaining 4 are identical. The rest of the cosets are either identical or same. H is an normal subgroup of G. H is a normal subgroup of G. That we need to show that now. We show that H is a normal subgroup of G. Let A belongs to G. H belongs to capital H. A belongs to capital G. And H belongs to small h. A inverse star H star A. A inverse star H star A belongs to capital H. That we need to show that. A inverse star H star A equal to A inverse star A. I can apply for commutative law. I can apply the commutative law. A star A inverse is nothing but identity, which is A star A inverse is the identity star H. E star H ingadhu H. Identity oda multiply panninga identity law. So H belongs to capital H. Therefore, A star A inverse, the small h you remove pananum belongs to H. So hence H is a normal subgroup of G. If we define the binary operation, some circle in between bracket, int, the operation star, some operation as the ordinary addition. This is indicating for ordinary addition. We see that, for example, I can choose the 2 left cosets, 1 plus h and 3 plus h. Just I can add the result. Normal addition meaning 1 plus h add panna h tama, 2h equal to h. 1 plus 3 is 4, 4 plus h. 4 plus h value is nothing but h. Some value is there. In general, if A comma B belongs to G, we see that A h, the operation BH equal to A plus B into H. Hence, G over H comma plus is a quotient group. So clearly, quotient group definition, we can see that quotient group is nothing but G over N, meaning NA such that A belongs to G. Otherwise, the binary operation NA star NB equal to N into A star B. The either N this side or this side. This is the right cosets and left coset. I can write the right cosets. A plus B H last term first to H. This is the left cosets I can write. Right cosets starting like H. G over H plus is a quotient group. It's a quotient group. It's nothing but it is a quotient group. That is a composition table. Question itself is asking, and also find the composition table. So the composition table is addition. So H, there are 4 distinct left cosets. 1 is H, 1 plus H, 2 plus H, 3 plus H. Similarly, the vertical also you can H, 1 plus H, 2 plus H, 3 plus H. Now try to add, in case more than 4 will become 4 plus h is h, 5 plus h, more than 5, இந்த element வந்து 4 or more than 4 இருந்தா can subtract the 4 or divide by 4 பண்ணி remainder வரும். Either subtract, you can write the remainder, you can write the remaining value, or divide by 4, write the remainders. So h plus h, 2h. 2h is nothing but h. That we can tell for here. 2h is nothing but h. H plus 1 plus h, same. 1 plus 2h, answer is 1 plus h. Here you can add 2 plus 3h, nothing but 2 plus h. That is identity சொல்றனால அந்த h இங்க group. 3 plus h also. The same logic you can apply for vertical also. Horizontal line, vertical line. 1 plus h, 1 plus h is nothing but 2 plus 2h னு வரும். அத 2 plus h னு எழுதிட்டேன். Number constant மட்டும் ஆட் பண்ணிக்கங்க. 1 plus 2, 3. 1 plus 4, 3. 4 னு வரும். 4 plus h is equal to h. இல்லனா ascending அப்படி ஞாபகம் வச்சுங்க. 1 2 3 4. 4 னா 1. இந்த ஆர்டர்ல தான் வரும். 2, அடுத்து 3. Next 4 வரும், 1. 5 வரும், answer is 1. 4 வந்தா 0, 5 வந்தா 1. 3 as it is 3. 3 plus 1, 4 na 1. 3 plus 2, 5 na 1. 6 na 2. That's all. This is the composition table. Cayley's table நம்ம எழுதாம this is called a composition table. Question composition table கேட்டிருந்தாங்க. Next, show that next theorem is show that kernel of a kernel. What is the meaning of kernel, ma? What is the definition of kernel? Kernel definition. Can you tell anyone what is the kernel definition, ma? Kernel k அப்படின்னு யூஸ் பண்ணுவோம். K equal to set of all the elements x such that E belongs to element. Every element, what are the elements in the domain which is mapped to the identity element in the codomain is called the kernel of the homomorphism. Kernel அப்படிங்கிறது input, அதாவது input வந்து any element, output எல்லாமே ஐடென்டிட்டியா இருக்கணும். So domain உள்ள element it should be mapped into the identity element to the codomain. The collection of set is called the kernel. Collection of element is called the kernel of the element. That is a definition of kernel. There is a fundamental theme of homomorphism also I can apply. Everybody should know the kernel. Kernel is most important definition. Okay, next. So now the statement. Show that kernel of a group homomorphism is a normal subgroup of the group. Or another way, the same question they can ask him like this way. Another way they can ask him for, let G comma star and G dash comma dot be groups and F is a mapping from G to G dash be a homomorphism. ரெண்டு செட் கொடுத்துட்டாங்க. G comma star ஒரு group, G dash comma dot ஒரு group. ரெண்டு group கொடுத்தாச்சு. மேப்புங்கிறது G ல இருந்து G dash க்கு ஒரு மேப் பண்றேன். be a homomorphism. இது எதுவுமே இங்க கொடுக்கல, நம்மளா தான் அதை அஸ்யூம் பண்ணிக்கிறோம். क्वेश्चन இதே மாதிரி கொடுத்துட்டா ஓகே, இல்லனா இத நீங்க can convert it like this way. Then the kernel of F is a normal subgroup. Normal subgroup na A star n star A inverse, that is belongs to capital N solita. Okay, let G comma star and G dash comma dot be the group and F is a mapping from G to G dash is a group homomorphism. Homomorphism is take a function f of product of two elements using the binary operation in the first set. It should be equal to the function of that element, separate element. The operation is dot product. That's not domain or product equivalent to the codomain or the product function. It's a group homomorphism. Then we know that f of E equal to E dash, where E comma E dash are the identities of G and G dash. G odd identity E no, G dash odd identity I can take it as G dash, E dash. Therefore E belongs to kernel F. ஏன்னா டொமைன்ல உள்ள ஒரு எலிமெண்ட் ஐடென்டிட்டி எலிமெண்ட் ஆஃப் த கோடொமைன். இங்க ஐடென்டிட்டி எலிமெண்ட் ஆஃப் த கோடொமைன் வந்து E dash. E dashக்கு மேப் ஆகும். அதாவது ஒரு ஃபங்க்ஷன் அவுட்புட் எடுக்கும்போது இங்க எந்த வேல்யூ போட்டாலும் அவுட்புட் E dash வந்துச்சுன்னா இந்த எலிமெண்ட் எல்லாமே கர்னல்ல இருக்கும். அப்ப clearly E belongs to kernel F. அப்ப கர்னல் வந்து ஒரு நான் எம்ப்டின்னு சொல்லலாம். கன்ஃபார்ம்டா கர்னல் அப்படிங்கிறது ஒரு நான் எம்ப்டி செட். ஏன்னா ஐடென்டிட்டி கர்னல்ல கண்டிப்பா இருக்கும். இஸ் a non-empty subset of G. Let x comma y belongs to kernel f or two elements எடுத்தாச்சு. f of x is equal to e dash, f of y equal to e dash. Then kernel இருக்கு அப்படின்னா இதான் டெஃபினிஷனை சாட்டிஸ்ஃபை பண்ணும். அதோட இமேஜ் வந்து e dash இருக்கும், இதோட இமேஜ் வந்து e dash. Both should be have the same images. Now f of x star y inverse எடுத்துக்கிட்டோம். Now f of x star y inverse, that is equal to f of x star f of y inverse, f of x star f of y inverse. Since f is a homomorphism, so f of x dot f of y to the whole inverse. Homomorphism அப்படிங்கிற ஒரு ஸ்டேட்மெண்ட்னால தான் இந்த ஃபங்க்ஷனை தனித்தனியாக என்னால் எழுத முடியுது. ஸ்டாருங்க ஆப்ரேஷன் வந்து டொமைனில் உள்ள டேர்ம், டாட்டுங்க ஆப்ரேஷன் கோடொமைன்லேருந்து யூஸ் பண்ணிட்டேன். So f of x star y inverse equal to f of x into dot f of y inverse. F of y inverse can be written as f of y the whole inverse. So f of x na e dash, f of y na e dash to the inverse. X e dash ku inverse eduthala again e dash na. E dash and e dash, that is identity, again e dash. So x star y inverse belongs to kernel f. So clearly a b inverse belongs to h ன்னு சொல்லிட்டீங்கன்னா x comma y belongs to h ஒரு குரூப்ல சப்குரூப்னு சொல்லணும்னா ஃபர்ஸ்ட் கண்டிஷன் h is a subgroup of g, then a star b inverse belongs to h ன்னு சொன்னா போதும். அதனால தான் அந்த a star b inverse belongs to kernel f. அப்ப kernel f is a subgroup of g ங்க கன்க்ளூஷன் வந்துட்டேன். இப்போ நான் எம்டி செட் சொல்லியாச்சு, சப்குரூப் சொல்லிட்டேன். ஒன்லி த திங்ஸ் இது நார்மல் நான் சொல்லணும், அப்பதான் நார்மல் சப்குரூப் கிடைக்கும். நார்மல் அப்படின்னா that is to pure a star a inverse belongs to kernel சொன்னா போதும். that is a star n star a inverse equal to n ன்னு சொன்னா போதும், capital N. For all n belongs to kernel f and for all a belongs to g. To prove f of a star n star a inverse equal to identity, எனக்கு kernel இருக்குன்னு சொல்லிட்டு it's enough. Let n belongs to kernel f be any element and a belongs to g be any element, and two elements g லையும் kernel லையும் எடுத்துக்கலாம். இப்போ f of n வந்து e dash, e dashங்கிறது கோடொமைனோட வேல்யூ, ஐடென்டிட்டி எலமெண்ட் இன் தி கோடொமைன். ஓகே, இப்போ f of e equal to g dash, f of e some element எடுத்துக்கிட்டோம், you can give some element a. Now f of a star a inverse, that is equal to, by applying the again homomorphism, f of a star f of n star f of a inverse. So but therefore I can take it as separately. I can take then the next one f of a, f of n value, f of n is e dash, and n belongs to kernel எடுத்ததுனால f of n ஓட வேல்யூ e dash நம்பர். இது f of a the whole inverse, inverse மேல கொண்டு போயிட்டேன். ஐடென்டிட்டியோட எந்த டேர்ம் மல்டிப்ளை பண்ணாலும் அதே ஆன்சர் தான். f of a into e dash is f of a தான் வரும். இது f of a the whole inverse. So a star a inverse equal to b. So f of a star f of a inverse equal to e dash, f of a equal to e dash. அப்போ therefore a star n star a inverse belongs to kernel f ன்னு சொல்லிக்கலாம். அப்போ hence kernel is a normal subgroup of G. That is a very most important. Hence kernel f is a normal subgroup of G. So H is a subgroup of G. அதே கான்செப்ட் தான் இப்போ first k வந்து நான் எம்டி, இதுக்கு ஐடென்டிட்டி இஸ் there. Next k is a subgroup of G சொல்லணும், x star y inverse belongs to kernel சொல்லிட்டேன். K is a normal சொல்லணும், a star n a inverse, f of a star n a inverse equal to identity கொண்டு வந்தாச்சு. So k is a normal subgroup னு ப்ரூவ் பண்ணியாச்சு. These are the things we are going to see, that k is a normal subgroup. So this is the most important some of the theorems, composition mapping, like etc. Normal subgroup and quotient group. Actually next, I think next one is the fundamental theorem of group homomorphism. There is very one more important theorem we can expect at 8 or 16 mark, that we can see in the next class. But the statement, this is the quotient group of base money, we can go for this one. So quotient group of base money and the theorems we can easily go. Fundamental theorem of homomorphism is the main. So once you can complete பண்றோம்னா Cayley's theorem நமக்கு, Cayley's theorem for permutation. That is also most important theorem. So once these two things are over, then last topic, rings and field. These are basic definitions and examples. Rings and definition rings. இதோட depth வந்து you can say algebra and number in 5th semester we can study these things. This is only 4th unit. These are things is there. Some only important theorems. அதில் named theorems பார்க்கும்போது straight and through the Cayley's theorem கேட்கலாம், named theorem. So right straight and through the fundamental theorem of homomorphism கேட்கலாம். and then state and prove the Lagrange theorem கேட்கலாம். இதெல்லாம் ஸ்டாண்டர்ட் சம்ஸ். நம்ம a, b belongs to H னா a star b inverse belongs to H subgroup சொல்றதுக்கு, நம்ம நார்மல் subgroup சொல்றதுக்கு. So very standard theorems are there. Okay, ma'am. So up to this you can go to. Students, if anybody got a doubt, ma'am,